So in this one, a rocket shot straight up into the air with an initial speed of 44 meters per second. How long does it take the rocket to reach its highest point? This again looks like it doesn't give us enough information, but so how long is time? You shot it with an initial speed, that's pretty clear. That's your VI, 44 meters per second. It was up, so that stays positive. Again, it's in the air. It's not being pushed by anything but gravity. So the acceleration is going to be due to gravity. So we say little g, and it is again negative 9.8 meters per second squared. For this free fall chapter, the acceleration is always going to be the negative 9.8 meters per second squared. Now the other thing, just to give you a hint, I put it in red, highest point. When an object, whatever it is, reaches its highest point after being thrown, vertically, it stops, speed-wise, for a split second. Its final velocity at that point would be 0 meters per second. Because, again, it goes up. This is from the notes, but if it goes up, as it goes up, it slows down. Gravity slows it down to where it reaches its highest point, where it hits 0 vertical velocity, and then gravity is going to speed it up as it comes back down. So there's your 4 pieces of information. They never mentioned anything about the displacement, so we're going to use it, just make it easy on ourselves. We're going to use an equation that doesn't have the displacement in it, which is Vf equals Vi plus Gt. And then we're going to plug in what we know. Vf is 0 because it's at the highest point. That is only true at the highest point. Vi, they said, was a positive 44. Gravity is a negative 9.8 t. So I'm going to add that to the other side. So I'm going to get 9.8 t equals 44. So we just divide both sides by 9.8. And that is our answer, which should be around 4.5 seconds.